just my opinion, remain dominant for a while. And that's chemical treatment. It's referred to as flock and drop. You coagulate, flocculate, and allow the material to settle. Electrocoagulation, which has some unique features that are very good in this application. Mechanical vapor compression, Meagan talked about that. And then biotreatment for more centralized facilities. So I'll go through each of these in turn. So the first thing to talk about, this is a little index that I invented. This is the ratio of the feed water quality. So if the feed water quality is high, you get a high number, to the effluent water quality. And what I mean by feed water quality, that's the water that you have to clean to feed to the well divided by the effluent water quality. So if this is a high number, then you have really dirty water coming in, and you have to clean it and make it very clean coming out. This is where the conventional hydraulic fracturing technologies reside in terms of cost. And these numbers, that's about $5 a barrel, that's about $10 a barrel. They are way up there in scale because in the conventional treatment, it's dominated by filtration. Cartridge filters, granulated activated carbon filters, right, coalescing filters, and so on, because all of that water gets discharged overboard. So those costs are way too high for unconventionals. So the unconventionals reside more in this space. There are other analogs, like a polymer flood, same polymers that are used in hydraulic fracturing. And then this is what you get into if you have to desalinate. So let's talk about 3 different stages or progressions in water treatment technology. The first, which we don't see that much anymore, is to secure the lease. The wells are stranded, wells are far apart from each other. The next is what I would call modular developments, where the wells are clustered, kind of a spatial, temporal concept that Meagan was talking about. And then as time goes on, more centralized facilities. So in the mobile, we're talking about a couple of wells, a treatment technology, some waste brine, and some reuse. And these are the sort of technologies that we're talking about. This, you can see the wheels of the truck. So this Found Quail Aquapure rover comes in 2 18-wheel trucks. You wheel it up to the site, treat water at about 7 barrels a minute for a few days, and then you've got enough water for the next hydraulic fracture. This is mobile evaporation. This technology never really took off. Very complex, and you'll notice 1 barrel per minute is a relatively low number. That means that that technology has to be on site doing water treatment for 7 times longer than this. And the economics of these technologies is the number of staff that you have to deploy at site for a given amount of time. The break even is about 6 or 7 barrels a minute. And then we've got the electric coagulation, which is also mobile technology. So on mobile technologies, it has been a real struggle in the industry. There haven't been that many, probably an overstatement, but requirements for mobile technology, it has to be simple. It has to be self-sufficient. So it has to be simple so that the operators can go out. And you have to have a staff of operators. If you're going to be serious about this, if you have a client and that client is drilling 3 or 4 different regions, 3 or 4 well clusters within each region, you have to be able to support them with a staff that can go out and operate the equipment. The equipment has to be very simple. When the staff get out there, they only have what they brought with them. So if you have a pump that breaks down, you have to have a spare. If you have other instrumentation or equipment that breaks down, it all has to be there. Because if you shut down a rig, it's going to cost you $200,000 a day. And there are many pieces to the puzzle. Let me just give an overview of who has tried to do this and what they've encountered. The guys from the oil sands, for example, in Canada and Alberta and so on, they understand the fluids. The fluids that they deal with for steam injection are also quite contaminated. What they didn't quite understand, in just my opinion again, although they did a fantastic job, is how to deploy the staff with spare parts. They're more experienced with centralized facilities and so on. As I said, the offshore hydraulic fracturing, this is the conventional. They understood the concept of remote deployment, everything has to be robust and so on, but they didn't have the technology. Like I said, they had the filtration, activated carbon, very expensive. You had the industrial innovators, the guys that brought electric coagulation from industrial water treatment into the oil and gas industry, they understood the technology, but they didn't know how to make it robust, easily clean. Shut down every 4 hours and clean it whether you need to or not, and just keep going. Have spares so that you can do that, equipment in parallel. All things considered, the pieces are all there. And I think over the next few years, we're going to see those pieces start to come together. Okay, I'm going to go quickly in the interest of time, but modular, the idea behind modular is you set up the equipment in a steel enclosure sometimes, and sometimes it's actually completely outdoor. It takes 5 days to set up. You run it for 3 months on one of these clusters, and that's where you can start to use things like evaporation. And then you've got centralized. Most centralized facilities are going to use some form of biotreatment if they're only getting rid of the organics, evaporation if they're getting rid of the solids. So this is just a rough kind of schematic of how, as connectedness of these wells increases, as more and more pipes get laid, and so on, as centralization occurs, cost is going to naturally come down. Okay, so let me just highlight a couple other things, and then I'm going to wrap up. So one of the technologies that has really changed things recently is the chemistry of the fracking fluids themselves. And this would be the saline-tolerant hydraulic fracture fluids. They're more expensive, they're more complex in terms of the chemistries involved, but they are very robust toward salinity. This is a sample from the well that has been treated to remove the suspended solids. Very high salinity in this case. I think it's about 270,000 milligrams per liter, and that was used successfully in a recompletion on a well, and this is already a couple of years ago. Let's see. So water quality requirements on water management. Okay. So then the other thing I wanted to talk about is that as part of my SPE activities, I provide training on water management for the oil and gas industry. And one of the things I do in that training is I give the students a cost model. So I have a bunch of different ways of transporting water, storing it, using brines and so on, and I give them the costs. And I say, okay, design the facility. Would you use salt-tolerant brines? Would you transport water? Would you build a lagoon and so on like that? And what I find so interesting is in a class of, let's say, 15 or 20 students, I will get costs that range from $1 million for this exercise to $4 million, and everything in between. I get all kinds of approaches. But one of the things that I try to do is get the students to think about salinity management. Right? Taking some amount of fresh water, some amount of brackish water, some amount of recycled water, blend those together to get the right salinity, and they're always reluctant to do that. I find the only students that are willing to do that are the ones that actually have a year or two experience at doing this. Everybody else shies away from it. So I find that to be interesting. So I guess in the last couple slides, I just want to point out technology development and uptake in the oil and gas industry is a very long process. This is technology uptake curves, where you start at the initial conception and then you start to implement the S-shaped curve until it becomes a best practice. Some of these timelines are 6 or 7 years. So we've been doing this now for about 6 or 7 years. And so we're beginning to see the bright spots develop in the industry. Of course, the thing that's going to hold us back is the price of oil. This is inflation-adjusted price of oil. And but I think we will end up entering into a period of technological consolidation. The oil and gas companies are still looking at technologies. They're still developing technologies, and they're still reaching out on how to manage their water infrastructure. That activity is still going on, and it's very encouraging. And they're also still looking at new technologies, but their tolerance for carrying a technology from early stages all the way through is beginning to diminish. They expect the technologies to be more or less ready to go based on others. So the paradigm shift in the mindset is, and then as well pumps and pipes and so on, things that should not be overlooked, salt-tolerant brines, and we're beginning to see the well site technologies. And so then I guess we're ready for questions.
So we're about to walk into the coffee break according to the schedule. So we're going to take about 15 minutes for some questions. So if you have a question, please step up to the microphone. Fire away.
This is a question for Megan. You characterize the impact fee as being inadequate in that it seemed to allocate too much money to localities where the drilling is occurring. But from my reading of the fee, you got right off the bat, 25 million goes to state agencies. 40%, and then you got 40% going to the Marcellus Legacy Fund, which is distributed across the state on more of an application grant need basis. Then you got the 60%, which some of which is allocated based on number of wells drilled, and a lot of it on highway miles and population density. And your map seemed to miss that fee because you didn't show any fee being allocated to Philadelphia or Allegheny County, which are top impact fee recipients within the top 7. So kind of with all of those different channels for impact fee money to go to places not receiving drill, not having any drilling, it seemed like the assessment was.
Yeah, so there are impact fees being allocated to but even just looking at the damages exclusively from the water treatment. Even looking just at the damages, so let me take a step back and tell you what we've done. We have the road patterns that are driven by the trucks. We can then use the Mueller's AP model to estimate ground level, or we use moves to estimate ground level emissions from diesel trucks, and we can translate that into dollars and damages. There's a lot of aggregation in major highways through Allegheny County as well as along IAEE. So we see that those damages, which average about $3,000 per well, are unequally distributed across the state, and that when thinking about these regional damages, the impact fees that are paid out to Allegheny County are too low for the damages that that county is incurring. So we don't look at what the actual allocation equation is within that 60%. We're just looking at the actual dollars paid of that 60% to the county, irrespective of whether they're getting it because of the high population or they're getting it because of eligible road miles. We don't care. We only care about the dollars that are actually allocated.
But that's excluding the 40% that might be coming through Marcellus Legacy.
That excludes the 40% entirely, and we make that very clear in this draft paper that we have posted on our lab website, which I'm happy to send to you. But given that the order of magnitude that we're off, it doesn't make any difference. Even if all of that money was coming to Allegheny County, it still wouldn't be enough.
And is it enough in the areas that do get a lot of wells? Or is there a shortfall there too?
No, so there's overpayment locally. Now, there are other local damages that are not accounted for in this, right? And we're the first to say that this is like, if you assume that 50, I have a backup slide, but I'm not going to put it up. There's, you know, if you look at the total health impacts estimates, 50% of that is air emissions, 10% of that is truck traffic, and we're 10% of the truck traffic is supposedly in waste transport. So it's a really small fraction. We're not saying that it's the whole fraction. But it is the only spatially resolved fraction that we have, other than compressor stations, which we don't have good emission estimates from. So I think that it's at least a starting point for thinking about how can we actually do measurement-based or operationally based impact fee allocation that better matches actual damages with impact fees.
Just a quick point of clarification. Does Allegheny County receive impact fees, or are they excluded from those because of the moratorium?
They do receive impact fees. So there was actually a lawsuit after this PA Act 13 came out. They still have to comply with two statewide regulations in order for the fees to be distributed. I can't remember which ones those are. I apologize.
That's
Again,
okay,
happy to
but
follow
it's
up.
not lower because they're excluded because of the moratorium. It's just lower.
I think it's just lower.
All right, thanks.
Yes. Because there was a lawsuit fighting.
Robert Kleinberg from Schlumberger. John described the sorts of chemistries that you can use with saline water to make viable hydraulic fracture fluids. I was just wondering, Meagan, whether in your study of water resources in China and other countries, it was considered that you could use substandard brines in places like the Tarim Basin. Is that realistic? I mean, I assume there are subsurface brines in the Tarim Basin.
Yeah, so I will just say that there are there's very, very little data on subsurface brackish water resources. The last assessment that was done in the US was in 1965 by USGS. Its resolution is a 100 pixel by 100 pixel TIFF image, and it stinks, okay? There's no quantification of depth with any precision whatsoever. It's even worse in developing economies, where most time people haven't bothered characterizing these resources. So I think that it's a big question mark. We brought it up as a recommendation, and in fact, I'm serving on the South African Academy of Sciences panel to look at shale gas development in the Karoo Basin. We do think that they have some subsurface brine that might be used. It's at a TDS of about 20,000 ppm, so it's totally viable, and it's certainly a better option than the alternative, which may be shipping water from the coast inland. So yeah, we really encourage them to use local water resources, given, especially that the Peru is a desert.
I'm from University of New Mexico, and I have a question for you. New Mexico has recently eased storing water in containment facilities for further use of it. And I wanted to know, during your research on risks associated with post-produced water reuse and management, did you see any specific risk to freshwater resources?
Is that for?
So what are the risks to freshwater resources associated with containment?
Yeah, like storing, I mean, is there any specific risk or any significant risk that can be associated with this storing water in these containment facilities, like two-liner lagoons or...
I see. So I think that actually this is a much better question for him. That, you know, there are always going to be low probability, high impact events, right? And that's totally unavoidable in any industrial operation. And, you know, the EPA was guilty of a high impact, low probability event when they opened this valve in Colorado and sent a bunch of water pollution right down, you know, a pristine river. Things happen, and I think that what responsible shale gas development industries do is minimize those risks to the extent possible through detection and monitoring and good practices. And they continue to kind of design systems that have the fewest moving parts, right? Because the fewest moving parts, the fewest different steps means that you have less likelihood. You want to elaborate?
So I think there's some data on the reliability of these impoundments from Brisbane with the coal seam gas. They have been desalinating the water coming off of the coal seams, using the desalinated water for agriculture, and then concentrated brine has been going into these impoundments. And they do see impoundment failures, not a high frequency, but it's what Meagan said, these are low frequency, high impact events, driven by inaccurate calculations of the embankments and what they call the attic that you know, basically supports the liner and so on. Also, you know, you're talking about having to train and manage crews of individuals to go out and what they call weld, how you put seams of this material together, and then test it. And that's the whole intent behind this detection layer, is to give another barrier of defense. But these systems do fail nevertheless, in part because it's so difficult to manage the process of installation.
So it's sort of an extreme and more or less long-tail rolling distribution function.
I would say so, and there's also data in the tailings ponds in Canada where they don't use the same technology, but it's a different type of impoundment. There's some information.
Thank you.
And as a resource for that question, the Sloan Foundation funded Resources for the Future to do a study looking specifically at the use of pits and ponds for storage in Pennsylvania. I'm not sure where they are in that process, but I think that grant was about 2 years old, so I'm sure they've got something published at this point.
Peter Hartwell.
So the oil industry produces a lot of water with the EOR process, and is there anything that's similar in what they're doing and what you're doing, or how do they get rid of their water, and what practices do they use, and how are they different from some of these things that we're doing, that we're talking about?
Yeah, go ahead.
You're talking about chemical EOR, and you're talking about polymer flood or ASP or what specifically?
All I do is like 7 barrels of water that comes out. How do they get rid of
Yeah, well, it's interesting that in chemical EOR, one of the applications is to use the same exact polymer that is used in Marcellus wells. It's the hydrolyzed polyacrylamide. It's called slick water. That's the same polymer, a slightly different molecular weight, different chain density, and so on. But the oil and gas industry is looking at technologies to clean that up. But there is a difference, okay? And it's important to understand the difference, and that is the polymer floods will typically be onshore, and which means that there's a dedicated, centralized water treatment facility. And those few, actually I can only think of one, Total's Dahlia facility, where they have done polymer flood offshore. They haven't yet decided how they're going to treat that water. Does that help?
Peter Harvey, I noticed Meagan said something about these companies spending much more trucking the water than treating it. It seems like they're leaving a whole bunch of money on the table. And here you're talking about the sort of how much learning is progressing. I guess the question I have is, do we have any information on how fast these firms learn in the learning process, how that sort of operates?
Yeah, that's actually a great question. It's work that we're doing right now, looking at learning by doing within the play and how fast those waste transport distances have dropped. I don't have good data for you at the moment, but I don't, the student left. So we're working on that, but I'm sure that you can learn.
Yeah, just one quick comment that I forgot to make when I gave my presentation, that is that there are still some operators who feel that trucking is their first option of choice because it gives you so much flexibility. It's so easy to change location, and at an early stage of field development, you're really hunting for those prolific seams. And so trucking is their preferred option, at least initially.
Last question.
This may actually be a question for you, Ken. Meagan talked about Pennsylvania Act 13, which is one way of compensating localities for cost of impacts on drilling and so on. My understanding is Texas does it differently, that they allow counties to levy property tax on declared reserves. How would you compare these two methods? Are they just, is one better than another, or is this just Texas versus Pennsylvania?
Good question. The one thing I would argue is if you levy a property tax on declared reserves, you're going to have to basically renominate what that tax value is as the price of oil change. So that can actually impact not only the revenue collection, but also the distribution of revenue. So there's a bit of volatility in that. Whereas an impact fee is directly related to the ongoing activity. So if that slows, then obviously revenue collections decline, but presumably so will the damages associated with it. So that's really all I'm willing to say at this point. I don't know the answer to that.